Oh, hello. What did one yoga lady say to the other yoga lady when she left early? Namaste. Okay, I thought that was a pretty good one. Speaking of stretching, we are talking today about dilations. Okay, now dilations, not the pregnant kind. These dilations are stretching. Okay, graphs. Um, and in this course, in advanced, we only really dilate in two directions, which is vertical and horizontal. Okay, so we're just stretching out these graphs. Now, vertical, I've just kind of shown you here, say, for example, if this original graph is kind of like a parabola, standard looking, if I dilate it by a factor of A, vertically dilated, it now kind of stretches vertically. Okay, so it stretches across this axis here. And so -1 now becomes, I wrote A, but it should be -A is the point, but it's dilated by a factor of A. So it's kind of like multiplied with a factor A. Now I'm going to talk about these ones because this becomes helpful. To replace your vertical dilation, you just replace Y with Y on A. Okay, now Y makes sense for vertical, which should also now make also sense for horizontal dilations. Okay, so when we're doing a horizontal dilation, it means that we're stretching it sideways, and very, very similar to before. So this is your original. What happens is if I stretch it to the side, what was 1 now stretches to A because I'm dilating with a factor of A. And the way we do that is replace X with X on A. Okay. So that's the idea of a dilation. And then there's one more term. This one's less important. It kind of makes sense. If you enlarge something, so both the horizontal and vertical dilations are the same factor, it makes these similar shapes, or it enlarges or makes something smaller. Okay, now, for example, if we have this triangle ABC and we kind of stretch it out vertically and we stretch it out horizontally, we get a similar triangle ADE. Okay, similarity means these two triangles are essentially the same shape, just kind of stretched out a little bit. Again, this diagram is not to scale. You can see it's a little bit off, but you get the idea. I can stretch ABC. I can enlarge it to give me ADE, same shape, just different size. Okay. This is what I hope the questions would somewhat look like. For example, we've got fx equals to x squared minus 2x. And what we're going to do is we're going to sketch on a set of axes. On one set of axes, the original function. What happens if we vertically dilate it by a factor of 3? What happens when we horizontally dilate it by a factor of 2? And we're going to vertically dilate the factor by a negative number, and we'll see what that does. Okay, so let's just take a note here. I'll come back to the sketching, but let's talk about each one. So for 2, vertically dilate means instead of vertically is y. So that means every time I see y, I'm going to replace it with y on my factor, which in this case is 3. Okay, so essentially, instead of fx, I'm going to write y on 3 equals to x squared minus 2x. And essentially what that gives me is, just to make my life easier, I'm going to put the 3 outside of here. So 3 times, I'm going to times the 3 to both sides. If I really wanted to, I could write that as 3x squared, take away 6x. I could. That would be my vertical dilation. Okay, we'll sketch them so you can kind of see the difference. For this third one here, horizontally dilated means I change my x to my x on my dilation. So in this case, it becomes x on 2. Okay, so that means my y, or my fx, if I really want to, and again, go to my original function, x squared minus 2x. Instead of x, I'm going to write x on 2. Right, so it's going to become x on 2 squared minus 2x. And again, if I wanted to expand all this out, this would be a quarter x squared minus x. Okay, because the minus 2 and the 2 cancel out there. Okay, now we've got one last one, number 4. If I vertically dilate it by a factor of -1, That just means that instead of y, I'm writing y on -1, which is just -y. Okay, so that means -y now equals to x squared minus 2x, again using my original function, and instead of fx, I know that now it's just y on -1, which equals to minus y. And from there, I'll rearrange to get a positive y, so it would just be minus x squared plus 2x in this case. So you can see it's just going to reflect it from positive to negative. Okay, so those are my 3, and let's try to sketch them all together. All right, the first one is, we'll color code these. So just the original function, x squared minus 2x. I'm going to write it as x bracket x minus 2. And the reason I do this is so I know my x-intercepts, which will be 0 and 2. So I know it'll be, let's try to line it up as well. So 0, and let's say that's 2. 0 and 2. I think my iPad can save me here. Close enough. Okay. Now, I know I didn't draw it perfectly, but mathematically, I believe that's 1. Is it? Yeah. Mathematically, that is minus 1. Okay. There's the original. Let's do the next one. I'll do this one in blue, vertically dilated by a factor of 3. So again, this was our equation. But all I know that means if I'm vertically dilating instead of minus 1, I'm going to multiply that to minus 3. Again, not to scale. It's minus 3. I'm still going to have the same x-intercepts. It's going to go through those 2 points, and I'll see if I can. Maybe I can fix it. Don't go by my grid lines, go by what I'm labeling. It's a sketch, not a graph. Okay, so that there I'm going to claim is -3, and it makes sense because I'm vertically dilating it by a factor of 3. Now, if I keep going, let's do this one in red, horizontally dilated by a factor of 2. That means I take my original, which is the green one, and then I stretch it out by 2. So -1, +1 now becomes 2. So it's going to line up with here, but I'm still going to have the same, it's still going to go through 0 because that there is going to be my constant ones. But now instead of going that way, let's see if I can, there's 0, that's 2, that would be roughly 4. And so I know, because it's parabola, the way I'm stretching it is to the right, it's going to look a little bit more shallow. I wonder if I can do better. I don't think I can. Yeah, no, first one was better. All right, the idea is it still goes through the 0. But we're going to go through this way. So you can see that all we're really doing is we're stretching it in different directions. The original, we're either stretching it to make it skinnier and taller, or we're stretching it out to make it wider and fatter. This last one here, it actually just becomes a negative of the original. So what ends up happening here, and let's do this in yellow, vertically dilated. You can sketch this if you want, but it ends up becoming whatever the green was. We're flipping it upside down. Okay, and that there is that. Okay, now there's one more. I think that's actually it. Psych. Let's stop it there. Hope you guys enjoy. Oh, let me double check. Yeah, no, that's the next topic. All right, see you guys in the next one. All righty, bye-bye.